This scale shows the dates of floods and the height of the water in the floods. How high was the water in the 1955 flood? Well, we can see the arrow for 1955 is here, so just below 2 metres. But to understand this scale, we need to work out what each of these lines represents. To get from 0 to 1, we have 1, 2, 3, 4, 5 lines. So 5 lines takes us to 1 metre, and because 1 metre is 100 centimetres, we can divide 100 by 5, and that will tell us how many centimetres each line represents. 100 divided by 5 is 20, so for each line you go up, that's an extra 20 centimetres. So if this is 1 metre, then we have 1 metre 20, 1 metre 40, 1 metre 60, 1 metre 80 centimetres, and then we can see that the arrow is between 1 metre 80 and 2 metres. So that's 1 metre and 90 centimetres. We could also write our answer as 1.9 metres or 190 centimetres. Now, how much higher was the water in the 1969 flood than in the 1948 flood? Well, the 1969 flood would have been 2 metres 60 centimetres, because remember, each line is 20 centimetres, so we have 2 metres, 220, 240, 260. And then the 1948 flood would be 80 centimetres, because we have 0, 20, 40, 60, 80. Now 2 metres 60 centimetres is 260 centimetres. So if we subtract 80 from that, because remember, when we're comparing two values, we're finding the difference, so we need to subtract, and that gives us 180 centimetres, which we could also write as 1 metre 80 centimetres or as 1.8 metres. A, B, C and D are the vertices of a rectangle. Write the coordinates of point B. So we can see point B here, and remember the first coordinate is the x coordinate, so we look down and we have 5, and then for the y coordinate we need to look across and we have 7. So the coordinates of point B are 5, 7. Point E is in the centre of the rectangle. Write the coordinates of point E. Again, from point E, to work out the x coordinate, we go down, so that's 3, and then for the y coordinate, we can draw a straight line across, and we get to 4, so the coordinates of point E are 3, 4. The diagram shows some shapes on a centimetre square grid. Which two shapes have the same perimeter as shape A? So remember, the perimeter is the length around the outside of the shape. So the shapes with the same perimeter as shape A are shapes D and E. And we can see that because with shape A, we can see in red that it goes either vertically or horizontally through 6 squares and then diagonally through 2 squares. And that's the same with shape D. We have 1, 2, 3, 4, 5, 6 squares it goes across horizontally, and then 2 that it goes across diagonally. Or with shape E, again we have 2, 4, 6 squares that it goes across either horizontally or vertically, and then 2 squares which it goes across diagonally. So because the distance around the outside of the shape is the same, we know that shapes D and E have the same perimeter as shape A. Here is a table. The tick in the box shows that 20 is a multiple of 10. Put 4 more ticks to complete the table. So remember, a multiple of a number is in that number's times table. So 20 is in the 10 times table, but 12 and 15 are not, so we don't want to tick these boxes here. Now 12 is in the 2 times table, so it's a multiple of 2. 15 is not in the 2 times table, but 20 is in the 2 times table, so we want to tick this box as well. Now 12 is not in the 5 times table, but 15 and 20 are multiples of 5 because they are in the 5 times table. A rectangle has an area of 36 centimetres squared. How long could the sides of the rectangle be? Give 3 different examples using whole numbers. Now to find the area of a rectangle, we multiply the length by the width. So something times something is 36. We could have 1 centimetre and 36 centimetre sides, because 1 times 36 is 36. Or we could have a width of 2 centimetres and a length of 18 centimetres, because 2 times 18 is 36 as well, and we can work that out because if we divide 36 by 2, we get 18. We could also have a width of 3 centimetres and a length of 12, because 3 times 12 is 36. So we've given 3 different examples and we've used whole numbers rather than decimals, but there is another possible solution here as well. We could have 4 centimetres times 9 centimetres, because 4 times 9 is 36. Now if we had a width of 6 centimetres and a length of 6 centimetres, though the area would be 36, we wouldn't have a rectangle, we would have a square. So we can't use 6 centimetres by 6 centimetres, we need to use one of these, or 3 of these. Megan wants to fill a bucket with water. A bucket holds 6 litres, a jug holds 500 millilitres. How many jugs of water does Megan need to fill an empty bucket? So we know that 1 litre is 1,000 millilitres, so that means 6 litres is 6,000 millilitres. But 1 jug is 500 millilitres. So to work out our answer, we could divide 6,000 by 500, or we could count up in 500s until we get to 6,000. So if we know that 1 jug is 500, that means 2 jugs is 1,000 millilitres or 1 litre, because 500 times 2 is 1,000, and we want 6,000 millilitres of water, and 1,000 times 6 is 6,000. 2 times 6 is 12, so Megan needs 12 jugs to fill an empty bucket, so to fill 6,000 millilitres. Now we might have got our answer more quickly by dividing 6,000 by 500, and really that's what we've done here. We've just used a different method of division. But remember, when we're dividing, what we can do is cancel our end zeros, and then we have 60 divided by 5, which is 12. So that's our answer. Part of this number line is shaded. Circle all the numbers below that belong in the shaded part of the number line. So on our number line, we can see that to get from one whole number to the next, we have 1, 2, 3, 4 lines. So each line represents 1 quarter. So this point here is 1 and 1/4 because it's 1 line after 1, and this line here is 1 and 2/4. But it's useful to compare these to decimals, so to change them to decimals. 1/4 is equivalent to 25 hundredths, so 1 and 1/4 can be written 1.25 as a decimal, and 2/4 is equivalent to 50 hundredths, so that's 1.5 or 1.50 as a decimal. So now we need to compare these numbers to 1.1 and 1.4. To do that, it's useful to write zeros on the end, because we can always write zeros on the end of decimals without changing the value of the number. So because 1.10 is less than 1.25, it won't be in the shaded space. But 1.40 is between 1.25 and 1.50, so we can circle 1.4. Now we need to compare 1 and 1/3. But we have quarters, and to compare fractions, we need the denominators to be the same. Now 12 is in both the 4 and the 3 times table. 1/3 is equivalent to 4/12 because 3 times 4 is 12, 1 times 4 is 4, and 1 and 1/4 is equivalent to 1 and 3/12. 4 times 3 is 12, 1 times 3 is 3. And now for 1 and 2/4, 4 times 3 is 12, 2 times 3 is 6. So because 1 and 4/12 is between 1 and 3/12 and 1 and 6/12, we know that that fraction is in the shaded part of the number line. So we have 1 and 1/3. Next, we need to look at 1 and 1/5. But again, we have quarters. Now 20 is in both the 4 and the 5 times table. So to compare these fractions, we can convert them to 20ths. 1/5 is the same as 4/20ths, because 5 times 4 is 20, 1 times 4 is 4. But 1 and 1/4 is the same as 1 and 5/20ths, because 4 times 5 is 20, 1 times 5 is 5. So that means 1 and 1/5 must be smaller than 1 and 1/4, because 1 and 1/5 is only equivalent to 1 and 4/20ths, so we don't want to circle 1 and 1/5. Here is a triangle. Calculate the size of angle X. So we need to remember that angles in a triangle always add up to 180 degrees. Now we have 34 and 39, so that's 73 altogether. So 73 plus angle X is 180. So we can work out angle X by subtracting 73, so subtracting the total of what we have from 180, and that gives us 107 degrees. Here is a grid made of squares. Shade 10% of this grid. So we know that percentages are fractions with a denominator of 100. But this question is tricky because we don't have 100 squares. We have 30 squares because we have 6 in each row and we have 5 rows. 6 times 5 is 30. So we know 10% means 10 hundredths, but we need to turn that into a fraction with a denominator of 30. But 30 isn't a factor of 100. So what we need to do is simplify this fraction first. If we simplify 10 hundredths, we get 1/10 because we can divide both the numerator and the denominator by 10. So if we know that 10% or 10 hundredths is the same as 1/10, then we can find an equivalent fraction to that which has a denominator of 30 because we have 30 squares. 10 times 3 is 30 and 1 times 3 is 3. So this tells us that we need to shade in 3 of our 30 squares. So it doesn't matter which 3 squares we shade, as long as we have 3 squares out of 30 shaded. That's the same as having 1/10 or 10 hundredths or 10% of our grid shaded. Marie is the presenter of a weekly radio show. She always plays 5 new songs for every 2 old songs. Last week, she played 15 new songs. How many songs did she play altogether? So we know that the ratio of new songs to old songs is 5 to 2. And we know that she played 15 new songs last week. Now 5 times 3 is 15, and 2 times 3 is 6. So she played 15 new songs and 6 old songs, which means that she played 21 songs altogether.